All right, I wanted to just come back to this circuit one last time and look at how you'd actually do a current measurement with your multimeter. You cannot do current measurements with the open scope. It really just has voltage inputs, which are the oscilloscope inputs. But the multimeter can measure both currents and voltages. So the basic idea for doing a current measurement is that you have to, snip the wires somewhere and uh, yeah, so you'd have to snip the wire somewhere and insert the multimeter. So unlike the voltage meter, the voltmeter where you can just directly connect it between two nodes without modifying the circuit, the ammeter, the current meter, you actually have to snip the wires. So for instance, what we could do is we could snip the wires there and insert the multimeter between the two places where the wire used to go. All right, so if we jump over to the actual circuit, remember this has been kind of rotated, but there's the circuit. That place where we were looking at snipping, so just jumping back there, so that place that we snipped right here is basically the same as this red wire right there. So if we wanted to know the current through that, all we'd have to do actually is just remove that red wire. That would be like the equivalent of snipping the wire. And I'm going to do one thing real quick and just make sure I put my resistors in the right place. So R3, the one on the right, should be 4.7 kiloohms. So let me go over to the resistor and measure. And so indeed, it does measure 4.7 kiloohms. All right, so now I can go over, well, let me also measure the voltage. Make sure that my open scope is set to the right thing. So I'm going to measure, put black on ground, and I'm going to put red on the positive terminal, or the output of the DC power supply. Okay, so that's at 1.85, which is where it was the last time I set it. So let me go back over to the instrument panel, set it to 4. And now if I go back, now it's 4.01. Okay, so everything is basically set as it should be in the circuit, and now I want to do that current measurement. So notice the input here. If you're doing something that's in the milliamp range or the microamp range, you're fine using this input. And so typically, well, for instance, what we've got here is 4 volts, and we've got, resistances that are on the order of 1,000 ohms or higher. And so taking 4 divided by 1,000, like 4 milliamps is the kind of scale we're looking at for current. That's exactly where we want to be for using the milliamp scale on the ammeter. So let's set that up. And I'm going to use, again, the convention where black is kind of the low voltage and red is the high voltage. So I expect the current to kind of be flowing from red to black. And let me put that in there. So basically I've just connected, directly to the resistance wires and to the resistor wires. And if we think back over to the circuit diagram, really what I'm doing is I'm just, I'm attaching one lead to this wire right here. I'm attaching the other lead to this wire right here, and that's basically making the bridge between them so the current can flow now, and then measure the current that's actually flowing through the multimeter. So when we switch back over, we see it's about 0.56 amps, and that's the kind of thing that we should be able to compare to a theoretical calculation in a pretty straightforward way. So that's the basic idea. How you end up, kind of snipping the wires and connecting will vary a little bit depending on which resistor you need to measure. So let me input this wire back. So suppose we wanted instead to measure the current, through another wire right here. We could actually say through this other resistor, which is I think the 3.3 kilo ohm resistor. We could actually unhook one of the leads of the of the wire. So where have we put a snip in? That would basically be like putting a snip right there. So we've unhooked that lead, and we have restored this lead. And now what we want to do is have the ammeter actually bridge between the node that would really represent any place we could grab onto on the side of the 1 kilo ohm resistor. So we can just grab its lead, and then we'll grab the lead of the second 3.3 kilo ohm resistor. So that would be the other way to measure it. So I realize it's all a little bit hard to see in there. Let me tuck those wires back. But really what we're looking at is, attaching one lead, so the red lead to high voltage. So we're imagining the current's flowing from high to low. Oop, just having a hard time seeing it. Okay, there. And then the other lead to the resistor. And this time, what I see is there is 0.79 milliamps flowing through the second resistor. So remember that resistor is still plugged in to ground. It's still plugged into ground, but the other end is kind of floating. It's not plugged in anywhere, but it's actually the ammeter itself is making the connection. And so kind of like what we'd expect is if we have a lower resistance, we'd have a little bit higher current. So we were measuring about 0.5 something milliamps through R3, and so we get about 0.8 milliamps through R2. And that's how you do that measurement. So yep, so you basically have to make a little cut in the circuit so the current doesn't flow there unless you connect the ammeter through, and then you send all the current that you're trying to measure through the ammeter, and then it gets its reading. So that's the basic idea.